Part 2, this is for questions 7 to 11. Question 7, the function g is defined by this for x greater than 3 over a. Because if x is equal to 3, then over a, the a will go, then you have 3 minus 3, which is a 0. So meaning you will have these two divided by 0, and any number divided by 0 is undefined. So that means the function becomes discontinuous when x is equal to 3 over a, okay? So where a is a positive constant, find the g inverse of x, and hence verify that if a is equal to 6, then g inverse then is equal to the g of x. So if I let my g inverse to be equal to y, then I'll take this y this other side, then we shall have x which is equal to the g of y. This is the same thing as saying interchanging x and y. So we have x, where there is x in the g, I'll put y. So we shall have x which is equal to 2 out of a y minus 3, then plus what? A half. Then I can take this a half this side. We shall have x then minus a half, which is equal to 2 out of ay minus 3. Okay, then we can cross multiply. So this one will multiply with this, but again, I will divide all through by this. So I will just switch these two. So we shall have ay minus 3 then is equal to 2 out of x minus a half. Now take the 3 this side. We shall have ay is now equal to 2 out of x minus a half. Okay, then plus 3. Now we can divide all through by a. In other words, I can say 1 over a times everything here. That is x minus 1 over 2, then plus 3. Okay, which I can write as maybe y, which is equal to 2 out of a, then times this, then plus 3 over a. Let me just leave it there actually. So that means the g inverse of x shall be equal to 1 over a into 2 out of x minus a half. There are many ways we can write this, okay? I can simplify this such that I don't have the half in here, and then I get one fraction here, then times the 1 over a, but that is wastage of time because they never told you to put it in any format. So this one, I'm going to leave it there. Then they said that hence verify that if a is equal to 6, then the g inverse is equal to the g of x. Okay, now let us put the value of a here, and then we see what we get. So for a, which is equal to 6, now we substitute in the g inverse. Maybe first let us substitute in g of x. So what will be the g of x? So this will be 2, then out of our a is a 6, then times the x, then minus 3, then plus 1 over 2. Maybe I'm going to make this one fraction, okay? One fraction. So we continue. This one is going to be the LCM here, just like you used to do in O-level. You used to have what we call the butterfly method. So to get the common denominator, you multiply these two, then you get this times that, and then this times that, not so. So we shall have 2 times 6x minus 3, then 2 times the 2, you'll get a 4, and then a 1 here will multiply with the 6x minus 3. So simplified, we shall have 6x here, then minus, this is 4 minus the 3, that will be a 1. So positive 1, then out of, this will be 12x minus 6. Okay, then let's go to the g inverse. The g inverse of x is going to be 1 over 6. I'm substituting here. Then into 2 out of, now x minus a half, and then plus the 3. Okay, now let us go. We continue here. What are we going to get? So this 6 is going to multiply everything here. So we shall have a 2, then out of, this will be 6x, Now 6 times negative a half, you'll get a negative 3, not so? Then plus, you have 3 times this one here, it will give you a half. Do you see that this one is actually what we are having here? So these two are therefore the same. You don't need now to waste time to again show this. So you just say this one is the same as 6x plus 1, then out of the 12x minus 6. Therefore, g inverse of x is equal to g of x, okay, when a is equal to 6. That is that. Question 8. The points 6, 1 and negative 2, 7 lie at the opposite ends of the diameter of the circle. Find the equation of the circle. Now let us sketch this circle here and we see how it looks like. So suppose this is my circle. I have the center, which I don't know. So if I have a point 6, 1, okay, then negative 2 has to be on the left of negative, or on the left of the 6, and then there is a 7, so it has to be up, because 7 has to be above 1. That means I have these 2 points like that. So I can put this one maybe around here, and then this other one, this other side, you see? So 6, 1, this is just a sketch. Then negative 2 and what? 7. That is that. Now, since this one is a diameter, that means it passes through the center of the circle. So the center of this circle is equal to the midpoint, okay? The midpoint of these 2 points, 6, 1 and negative 2, 7. So how do we get the midpoint? You get the average of the x coordinates and then also the average of the y coordinates. So what do we get here? 6 minus 2, that is a 4, divided by 2, that will be a 2. And then 8 divided by 2, that one will be a 4. Now, you know that when we are finding the equation of the circle, we need the center, which we have gotten, and then the radius. So to find the radius, I can find the diameter, then I divide it by 2, or I can use this center and maybe this point or this point, okay? Now I'm going to use these 2 points that are given. So our radius is going to be equal to a half, then the square root, change in x will be 6, then minus 2 squared, and then the change in y will be 1, then minus 7, and then squared. So what are we going to have here? This is 8 squared, that is 64, then plus, this is minus 6 squared, that is 36, and then this one will give us 100, then root over 100 is 10, then a half of 10 is of course what? 5. That means the equation of the circle is going to be x, then minus the 2 squared, then plus y minus 4 squared, then is equal to 5 squared, which is 25. And this becomes our answer. Then part B, there are 2 tangents to the circle which have gradient negative a half. Okay, that means those 2 tangents, if they have the same gradient, then they must be parallel. Okay, find the exact values of the x coordinates of the points at which these tangents touch the circle. Okay, so I will say here 2 tangents. What have I written? 2 tangents with the same gradient are parallel to each other. Because parallel lines have the same gradient. Okay, now we are going to have this circle of ours here, and we are seeing that the center is, okay, let me just duplicate this one here. because I think it has some reasonable size. So I have these two tangents have a gradient of negative a half. So but you know that a gradient is always perpendicular to, and by the way, they never told us that the tangents here pass through maybe any of these points, okay? So I'm going to put them off here. Then also this one, I put it off. I only need the center, okay? Put off this. So the center here, what is the center? Our center is 2, 4. Then let me also take away this and also this one here. Now, remember, I've said that if a line is having a negative gradient, then it is slanting like that, not so. So I'm going to draw a tangent here, and then that same tangent, I'll draw it this other side like that. Okay, they are parallel, but then there has to be that line that passes through the center here. You know that any tangent, it is always perpendicular to, any tangent is always perpendicular to the radius or the diameter. You see that? So now we need to find now the equation of this line here. Are we there? If we find the equation of this line, then we shall solve it simultaneously with the equation of the circle. Then we shall be in position to get the x coordinates that are here. You get me? Okay, now gradient of, I can say the normal, because a line that is perpendicular to the tangent, we call it the normal. So gradient of the normal through the center, I can say through the center of the circle, through the center 2, 4, then will be equal to, we have -1 over -1/2, which is equal to 1. Remember, for two lines that are perpendicular, the product of their gradients is always equal to -1. So we have m1, then m2 is equal to -1. Already m1 is -1/2, so we are looking for m2. That means you get -1, then divide by the m1 you have gotten, not so. So that is that. Now I can find the equation of this normal. Equation of this normal here. Now remember, to find the equation of a straight line, we need a gradient. What did I write here? This one is supposed to be a 2. Pardon me here. A 2. We need the gradient and also one point through which a line passes. Now this one passes through the center. So we shall have y minus y1, which is equal to m into x minus x1, not so? So we have y minus our y1 is a 4, then m is a 2, and then this one will be x then minus x1, which is a 2 also, right from here. So make y the subject, y will be equal to 2x then minus 4, then bring this 4 here. So that means these 2 will go, and then the equation of that normal, or the equation of that diameter, is y is equal to 2x. Now solving y is equal to 2x, and the equation of the circle, which is x minus 2 squared, then plus y minus 4 squared, which is equal to 25, simultaneously, then we shall have, where there is y, we put the 2x. So 2x then minus 4 squared then is equal to 25. Now I can have x minus 2. You can expand, then you have the quadratic equation. But what I'm going to do, I'm seeing something common here, plus if I factorize out a 2 here because it is common, I'll have x minus 2 again, then squared, which will be 25. Then we have x here minus 2 squared, then plus 2 squared, that will be a 4, and then x minus 2 is also squared, which is equal to what? 25. Now the one which is here plus the 4, because this one is the same as this, then we shall get a 5. So 5 of x minus 2 squared then will equal to the 25. Then divide all through by 5. What shall we have? That is x minus 2 squared will be equal to the 5. Okay? Then take the square roots. You know that when we do so, we have plus or minus. Okay? Then take this to this side. We shall have x, which is equal to 2, then plus or minus the square root of 5. So these are our two answers. The first one is when you consider the plus, then the second one is when you consider the minus. Did they say exact? Yes, they said exact values. So leave the surds there. So that is our answer there. Question 9, the diagram shows part of the curve with this equation here and the line y is equal to 4.5. Find the exact volume of the solid formed when the shaded region is rotated through 360 degrees about the x-axis. Now, when I rotate this one about the x-axis, we are going to have something repeating itself maybe like this. We are going to have a mirror of this one here, okay? You will have a mirror of this one, so it comes like this, in the x like that. Then there is this line here, which is y is equal to 4.5. So we can put, this is y then is equal to negative 4.5, not so, because this distance has to be equal to this distance here. Then from there, so this one will come like this, and then we'll also, maybe, how will it come about? So this one will get in like this, then it keeps on reducing like this as it comes like that. Okay, then you have something like that. So you are going to be having something that looks like that. So let me shade this one also. Now, in here, we are going to divide this one into very many what? Strips. Okay? Into very many strips. Now, if I pull out a strip, this one here, you will get a cylinder. If you can see this very well, you can get this. That is a cylinder. Now, when I pull out that cylinder, I'm going to put it here. So we have something like this, then like that. Now, in that cylinder, a cylinder must have a radius, okay? So that is from here up to here. But you can see this is a vertical distance. This arrow here, it is equivalent to a value of y. You see that? So this one is equal to y. Then this other one here, from here up to here will be the height. This one here is the height, but it is a distance between an x value here and then another x value here. You see that? So that one will be a delta x. Now, for us to get the volume of this cylinder here generated, we are going to have this cylinder here plus this other one plus this other one plus that other one. So all of them together, okay? But you know that volume of a cylinder is equal to pi r squared what? H. So this will be pi, then y squared what? The h is delta x, okay? Now, I'm going to rub off everything here, okay? Now, what are we going to have here? We are going to put all of these cylinders into one, okay? It becomes one. Now, when we are rotating, you can see that this one is above this one. So the area we are rotating is this and then this. So we are getting volume got when you rotate this one here. Only the what? This line here, the triangle. So when you rotate it, then you are having something like this. Only this one here. But then you will subtract also the volume generated for the area that is below this. Okay? Just as you find area between a line and a curve or between two curves, Okay, that area there, you get the one that is above, then minus the one that is down. Okay, so right from this one here, we are supposed to look for the y squared. Okay, we have to get y squared. Now, y is equal to a half of x, then plus 4 over x. That means y squared shall be equal to this a half of x, then plus 4 over x, then squared. Now, what are we going to do next? Square this one here, you will get a quarter x squared. Then get this 2 times this times that. So, of course, that 2 will cancel with this one. So, you will have an x, which will also cancel with this one here. Then you remain with only 4. Okay, so plus 4 here. Then plus square this one here, 16 over x squared. Now, also another thing, let me first label this one here. Y is equal to 4.5. Now, we need to integrate from this point here to this point here. Okay. Now, to put all of these cylinders into one thing, that is the integration. Okay. Now, we need to find the point of intersection. So we solve these two simultaneously. So solving y is equal to 4.5 and y is equal to a half of x, then plus 4 over x. We just equate the two. So this is a half of x, then plus 4 over x. This one is equal to 4.5. Okay. Now, the LCM here is going to be, or the common denominator is going to be 2 times x. So I'm going to multiply it all through. So times 2x. When I multiply this one with 2x, the 2 will cancel, and then we get x squared, not so? Then multiply here by 2x, the x will cancel with this one, then you have 4 times the 2, which is 8. So we shall have an 8 here. And then 4.5 times 2, that will be a 9. So we shall have 9x. Bringing this one here, we shall get x squared, then minus 9x plus 8, which is equal to 0. So that is a quadratic equation we are supposed to solve. And then it gives us the two coordinates here, the x coordinates, one here and then the other one here. So two numbers, when multiplied, they give us 8, but when added, they give us negative 9. So that one, those two numbers have to be negative 1 and then negative 8. You can solve this on a calculator. So we have x is equal to 1 and then x is equal to 8. Now, our Vx will be equal to the integral of x. Now, since this region is in between two, it is in between the line and then the curve, so we shall get this one here, we square it, then minus this one down, squared. Okay, so we shall have y1 squared, then minus y2 squared, then with respect what to x from a to b. Now, what is my a? My a is this 1 from one x coordinate, then to another, then to 8. I can put pi outside because it is a constant. Then we have that 4.5, okay, squared, because the line is above and that y is equal to this 4.5. So you square this one, right? Then minus what we got here, this other y squared. So we have a quarter, then x squared minus 4 minus 16 x power negative 2. So remember this minus, okay, affects everything. So that's why I'm writing minuses here, okay? Then what else do we have here? We have pi. Is there anything to simplify? Yes, maybe. So 1 to 8. This one here is 9 squared. You know, 4.5 is the same as 9 over 2. So 9 squared is 81. Then 2 squared is 4. Then minus the 4 here. So you have 4 times 4, that is 16. So 81 minus 16, 4.5 squared, then minus the 4. That one gives us 65 over 4. So I can write this as 65 over 4 simplified minus a quarter, then x squared minus 16 x to the power of negative 2, then dx. Now let me begin the integration. When we start the process of integration, now based on the space that I'm having here, let me extend this one a little bit here. We take away the integral sign, okay? Usually students do this mistake and they say, again, integrate, then 8, yet they are going to put the results of integration here. Math is a language, so when you do that, that means you're going to get things wrong, okay? So we have now replace this integral sign by the square brackets. So when we integrate this one with respect to x, we shall get 65 out of 4 of x. Then here you increase the power by 1. You have a quarter, then x cubed, then over 3. This 3 will multiply with the 4, and then you get a 12, not so. So we shall get x power 3 out of 12. And then how about this one? You get negative 16, then to the power, 16x. Increase the power by 1, you get a negative 1 over the new power. Then negative 1 and then negative 1, you'll get a positive. Then you use rules of indices. This one you can take it down. That means we can have positive 16 out of x, then 8 and 1. Now let us put the limits. When we put 8, we shall have 65 out of 4 times 8. Now let me leave it like that. Then minus 8 cubed out of 12, then plus 16 out of 8. Then subtract, put 1, we have 65 over 4, minus 1 cubed, that is a 1 over 12, then plus the 16, like that. So here we are going to have what? 65 over 4, then times 8. Already 4 goes into 8 2 times. So 2 times 65, that is 130. Then minus, we have 8 cubed, then out of 12, and then plus 16 over 8, that is a 2. So 268 over 3, we have 268 out of 3. Remember there is a pi here. Then minus, what do we get here? 65 out of 4, then minus 1 out of 12, and then plus 16. This one gives us 193 over 6. 193 out of 6. Then what is this whole thing altogether? 268 out of 3 minus 193 out of 6. This one gives us 343 out of 6. 343 out of 6 of pi. I'll leave it exact. Did they even tell us to find it as exact? Yes, they said find the exact volume. So don't turn it to decimals and you write your 3 significant figures. This has to be the final answer. Question 10. A function f is defined by f of x is equal to this for x being real or real values, where p and q are constants. Part A. It is given that p is equal to 2, q is equal to 10. Express f of x in this form here. So first of all, we are going to have f of x, which is equal to 2x squared, then plus 4x, and then plus 10. There are two methods I'm going to use here. Like I've always done, you choose the one that is simpler for you, okay? But here we are using completing what? Squares. That is the idea. Now, if I'm having this f of x, which is equal to the 2x squared plus 4x, then plus 10, I'm going to first make sure that the coefficient of x squared is a 1. So since this is an expression, then I factorize out that coefficient of x squared. So put the 2 out here, then you will have x squared, then plus the 2x. If you want, you can say 5, then you close, but I want to leave the 10 out. like that, and then I put 10. Now I'm going to complete squares here. Now we have an identity that if you have x plus b squared and you try to expand, you get x squared then plus 2bx then plus the b squared. But then I want these two terms in x to be on their side. So that means I will bring this on this side. So we shall have x plus b squared then minus b squared, which is going to be equal to x squared then plus 2bx. Now I want you to see what is here. It's a b, and also here it is a b. But when I look at the right, we are having 2b. That means they got the coefficient of x, they divided it by 2. Then after getting it, they put it inside here with the b, with the x, and also they popped it outside as a square. So it's the same thing that I'm going to do here. I will say 2, then get the coefficient of x here, divide it by 2, you will get a 1. Now put it together with the x here, then pop it out here as a square. Okay, then there is a plus 10 here. So when you expand this, you will actually get what is here. Now multiply all through by 2, open the bracket. So we have x plus 1, then this one will be squared, and then minus, this is 1, then times the 2, that one will be a 2, then plus 10. That means our final answer is going to be 2, then into x minus 1, 10 minus 2, that one gives us a positive what? 8. So this is our answer here. Now, that means our A is a 2, then B is the negative 2, and then the C is the 8. Don't get confused that here you are seeing a plus, but inside here, actually I'm the one who made a mistake. Pardon me. So this one has to be a plus and a plus. But still, you can have a minus here, and then here you are having a plus. It's no problem. Now, we are also having a square there. So alternatively, you can expand and then equate coefficients. Okay. Alternatively, we can have this one here. Then we say they have told us to express it in this format. So we put a, then x plus b, then squared, and then plus the c. So this is 2x squared, then plus 4x, then plus 10, which is the same as, expand the brackets. So we have a, then x squared, plus 2bx, then plus b squared, then plus c. So 2x squared, then plus 4x, plus 10. This one is the same as, open the brackets now, we have ax squared, then plus 2ab of x, then plus ab squared plus c. Now look at the coefficient of x squared and then the one here. So they have to be equal, because even here I've put the 3 equal signs, meaning whatever is this way implies what is on the right. Okay, so from here, this one will imply that our a is equal to 2, and then the coefficient of x is a 4, which is equal to the coefficient of x is 2ab. So that is 2, our a is a 2, and then our b here. So this is a 4, then divide all through by 4. That means b is going to be equal to 1. You see that? Then go to the constant part, that is 10, which has to be equal to whatever is here. So our a is a 2, our b is a 1, okay, then plus the c. So bring this to this side, 10 minus 8, then c becomes a 2. And then we can conclude and say that these ones here, I'll just drop this one down. Then where there is a, I put what? Let me actually use this. So you go away, you also go away. Now what have I written here? It is 10 minus 2, which is equal to what? 8. So we shall put an 8 here, a 2 here, and then a 1 here. So that is that. Choose a method which is easier for you. Next, state the range of f. Now here, this f here, Now this is part A. It has Roman 1 and Roman 2. So the Roman 2 is also under this where P is equal to 2 and Q is equal to 10. Now here, the X values, real values, it is open-ended, okay? Now the coefficient of X squared is a positive. If the coefficient of X squared is positive, that means we are going to have a U-shaped what? Curve. So if we have that U-shaped curve, then its a turning point is going to be get this one and equate it to 0. You will get a -1 as the x coordinate. And if we have -1 here, this one goes, and then the y coordinate will be that 8. So in other words, these are the coordinates of the vertex. Okay. Now, for any value of x apart from this -1, it will give a y value that is above. Okay. So whether the x coordinate is on the right of this turning point, the y value is going to be above this 8 here. Okay. Whether it is this side here, the y value is going to be above the 8. So meaning that this one is the smallest, this one is the minimum point, and this 8 here is the smallest value of y. So that means the range of f, it has to be f of x, then greater or equal to 8. So I'm putting greater or equal to 8 because remember this is open-ended, okay? So if the domain is open-ended, then that means even the x value here is inclusive, okay? So that is that. Part B, it is given instead that q is equal to -5 and the roots of f of x is equal to 0 are 5m and negative 9m, where m is a constant. Find the values of p and the values of m. Now, if these two are roots, that means when they substitute them in the equation of the function, then we must get a 0, okay? So what we are going to do here, I can actually find, there are two methods maybe that I can use here, okay? The first one, I can substitute these two values, okay, in this function here, wherever there is what? X. So I substitute in here, okay? Then after that, those two are equal to 0. Then I can solve the two, okay, simultaneously. Then from there, the other method can be, I find a quadratic equation, okay? I find a quadratic equation that is coming from these two, okay? And then I just equate. So let us use those ones. Finding a quadratic equation whose roots are 5m. In fact, let me say x is equal to 5m and x is equal to -9m. Now, let us solve backwards. Bring this one here. We shall have x minus 5m, okay? Then also bring this one here. You will have x plus 9m, which will be equal to what? 0, not so. So if we have that, now we can open the brackets. So when we open the brackets, remember before you come to these two, you are having this factor, then you are equating it to 0 to come to that, and also this one to that. All right. Now, open the brackets. We shall have x squared, then plus 9xm, then minus 5mx. Okay. Then again, this times that will be minus 45, then m squared, which is equal to 0. So you have x squared, then this is 9m minus 5m. What do you get? You get a positive 4m of x. Then minus 45m m squared, which is equal to 0. Now, they told us that q is equal to negative what? 5. Now, for q, which is equal to negative 5, what do we have? Let us check again here. We shall have px squared, then plus 4x minus 5. Px squared plus 4x then minus 5 will be equal to what? 0. So we are having now these two. So this simply implies that the px squared plus 4x minus 5, okay, this expression here has to be the same as this, okay, x squared. Now actually, I'm going to divide through. I have to get a quadratic equation. The coefficient of x squared has to be a 1, okay? Just like this one here. This is the quadratic equation, okay, for these two roots. And these two roots are coming from this quadratic equation when q is negative what? 5. You see that? So what we are going to do, divide all through by p. So we are going to have x squared, then plus 4 out of p of x, then minus 5 out of p, which is equal to 0. So this implies that x squared plus the 4m of x minus the 45m squared then is the same as this x squared then plus 4 out of p of x and then minus 5 out of p. Now we are going to equate coefficients. Already this one is a 1, okay? Then we have 4m will be equal to 4 out of p, not so? 4 out of p. So this one will go, the 4 will go, and then m will be equal to 1 over p. Now, you come to this one here, the constant part, okay? Now, the constant part here, we have it as negative 45 of m squared. This one will be equal to negative 5 out of p, okay? Now, divide all through by negative 5, then you will have 9m squared, then it will be equal to 1 over p. You see that? Now, we are having these two equations. So this is the second one, this is the first one. Okay, this is the first one. Now, what do you see? We are going to solve these two simultaneously, not so? This is the first one. Now, 1 over p is equal to m. So that means 9m squared is equal to m. Okay, bring this one this side. Then you will have 9m squared minus m is equal to 0. So you have m and then 9m minus 1 is equal to 0. So that means from here, m is equal to 1 over 9. M can also be equal to 0, but this one is rejected because if m is 0, okay, then we are going to have a 0 here and a 0 here. You are only having x squared, okay? And yet, this other one here has gotten the terms in x and the constants. So we are taking 1 over 9. Now, what will be p? We are substituting now here. So if m is equal to 1 over p, this means that 1 over 9 then is equal to 1 over p. When you cross multiply, then p becomes a 9. That is that. So these are the two values. Then the other way you can do this is to substitute these two values, the 5m and the minus 9m, into the f of x. Each of them will give you a quadratic equation. You will solve it. You will solve the two simultaneously. Then you get your answers. But I'm just using this one here. Question 11. The equation of the curve is this one here. Part A, find the coordinates of the point at which the tangent to the curve at this point intersects the line, this one here. Okay, now we need to find the equation of the tangent to this curve at this point. Then we solve it simultaneously with the equation of this one here, and then we get our answers. Now, you know that to find the equation of the tangent, you need number one, the gradient. Then number two, a point through which this line passes. At least we have that point. So we need to find the gradient. And the process of finding the gradient of a curve is the same as differentiation. So we use differentiation to find the equation of the curve. Not so. So y is equal to 3x minus 8. Now, you also know, of course, using indices, this one will be to the power of -1, then 6, then x minus 1 to the power of -1. I was saying, you also know that if I'm having a curve and then I have this tangent here, at their point of intersection, they have the same gradient. Gradient between any 2 points on a straight line is always constant, but the gradient on a curve keeps on changing. So that means where they meet, they have the same gradient. You see that? So this simply implies that when you get the dy dx, when you differentiate the equation of the curve, it gives you the gradient function, and that will be the gradient of the tangent. So what is our dy dx? This one will be, bring the -1 here, it multiplies with the 8, then reduce the power here by 1, then it becomes a -2, then times the derivative of this one here, which will be a 3 using chain rule. The same thing happens to this. So we have -6, then times the -1, that is when you drop this power, then x minus 1, then to the power of -2, and then times the derivative of this, which is a 1. So what is therefore our dy dx? This is 3 times 8, that is 24. So we shall have -24, then out of this 3x minus 8, then squared. Using rules of indices, when I take this one down, the power becomes a positive, not so. And then -6 times -1, that one becomes a positive. Then we take the x minus 1 down, like that. Now, at this point here, 3, 5, what will be the dy dx, which happens to be the gradient of the tangent? It is going to be the gradient of the curve, but also the gradient of the tangent. So 24 out of 3 times 3, which is a 9, minus 8, which is a 1, then squared, it is still a 1. Then you have the 6, then 3 minus 1, then squared. So what do we have here? This is -24. Already this one is a 1. Then plus the 6 here out of 4. Okay? 6 out of 4. So this is -24 plus 6 out of 4. By 3, 2. By 2, 3. Then by 2, 2. So we have a 3 over 2 here. Now, this times that, what do you get? -48, then plus 3, that will be -45, then out of 2. So this one will give us -45 out of 2. So therefore, gradient of the tangent is going to be equal to -45 out of 2. We have gotten the gradient, and we have a point through which this line passes, which is 3, 5. Then we can find the equation of the tangent. So to find the equation of the tangent, then I'm going to use the general equation y minus y1, which is equal to m into x minus what? x1. So we shall have y minus y1 is a 5, then m is -45 out of 2, then into x minus what? X minus 3. You see that? Now, solving this one, okay, simultaneously with which other one? This one here. Now, if you want, you can simplify this further, okay? But I'm leaving it there. And then I say solving y is equal to -8x and this one here, okay, and this simultaneously. So what do we do? Where there is y in here, you can put this minus 8x. So that means I can have minus 8x, then minus 5, which is equal to negative 45 out of 2 into x minus 3. Then we can cross multiply. This one will give us negative 16x, then minus 10. Then negative 45 times x, we shall have negative 45 of x, and then negative 45 times the 3, isn't that 135? That is 135. So bring this one this side, negative 16x, then plus the 45 of x, then will be equal to, take this one this side, and then you will have 135 plus the 10, okay? Then 45 minus 15, that one gives us a 30, then minus 1, that will be 29. So we have 29 of x, which is equal to, this one will be 145. What will be our x? 145 out of 29. 145 out of 29. What do we get from here? 145 divided by 29, 5. So this one is equal to 5. That is the x coordinate. Then the y coordinate, I can use this equation here, or I can use this one here. You see that? But better to use this simple one here. So that is negative 8, then times the 5, which is negative what? 40. Not so. That means the coordinates of the point of intersection, we have the 5 and then the negative 40. That is that. Actually, let me take this one a little bit down such that it is not so congested. Just like that. Part B, Roman 1, find the x coordinates of each of the stationary points of the curve. You know, for the stationary points, dy dx is equal to what? 0. So for stationary points, dy dx is equal to 0. What is our dy dx? Our dy dx, we got it here, okay? Negative 24 over 3x minus 8. Negative 24 out of 3x minus 8. Then plus 6 out of, is it x plus 1? Or it is x minus 1. Let me first put x minus 1 squared. Okay. This is 3x minus 8. The other one is x minus 1. All of them are squared. All of them are squared. So we equate this one to 0. Now I can take this one this side. Then we have 6 out of x minus 1 squared, then will be equal to the 24 out of 3x minus 8 squared. Now, this 6 here can go here 4 times, okay? Then we can cross multiply. We shall have 3x minus 8 squared, then will be equal to 4 into x minus 1 squared. You see that? Then we can now open the brackets, or I can bring everything on one side and then we use a difference of 2 squares. So this is 3x minus 8 squared, then minus, this one is the same as 2 into x minus 1 squared, like that, which is equal to 0. Now we have 3x minus 8 squared, then minus, when I enter the 2 in the brackets, we have 2x minus 2 squared, which is equal to 0. This is the difference of 2 squares, so we have 3x minus 8 plus the 2x minus 2. Then remember, for the difference of 2 squares, we have a squared minus b squared is equal to a plus b, and then a minus b. Okay, so this is my a, this is my b. So I add them, then I subtract them. So we have 3x minus 8, 3x minus 8, then minus the 2x, but then the 2 here will be affected by the negative, so it will become a plus, then it's equal to 0. So we shall have 3x, no, we shall have 5x, because we have 3x then plus 2x, that is 5x, and then minus 8 minus 2, and don't we get minus 10? And then in here, 3x minus 2x, we shall get an x, then minus 8 plus 2, that's a minus 6, which is equal to 0. So you equate this one to 0, that means your x is going to be equal to 5. How? 10 divided by 2, that one is a 2. And then when you equate this one to 0, then the x is going to become a 6. Those are the two x coordinates they wanted us to find, not so. Yes, x coordinates only. So those are the ones. Then find the second derivative and hence determine the nature of each of the stationary points. So we have our dy dx here. So dy dx is negative 24, then 3x minus 8 power negative 2, then plus the 6 into x minus 1, then power negative 2. Now the second derivative, you differentiate the dy dx, so you differentiate this one again, because it is the same as saying d dx of dy dx. So the d, then the d, then it gives you the d squared y. You see that? Then dx, then we put this. But it is actually read as d2y dx squared, not d squared y dx squared. No, it is d2y dx squared. Now, drop this one here. It is negative 24 times negative 2, then 3x minus 8 to the power of negative 3. Enter inside here and you differentiate, you get a 3. Then plus 6, then times now the negative 2. Remember, I'm dropping this power. And then I'm reducing the power by 1, so it becomes a negative 3. But then we are multiplying by the derivative of this, which is a 1. So this one now becomes, so what is 24 times 2 times 3? 24 times 2 times 3, that is 144. So 144. Then we take this one down because it is a negative, the power is a negative, using rules of indices. That is 3x minus 8, then to the power of 3. And then this one is going to be a minus. So we shall have negative 12, and then x minus 1 cubed. Now for x, which is equal to 2, we substitute in the expression of this one, and then after that we look at the sign of the dy dx. If the sign of dy dx is a positive, then that means the stationary point is a minimum. If the sign of this second derivative is a negative, then the stationary point is a maximum. So what is our d2y dx squared here? We shall have 144 out of 3 times 2 minus 8 cubed, then minus 12 out of 2 minus 1 cubed. This one gives us what? 144 we divide by 3 times 2, that is a 6 minus 8, that's a negative 2, then to the power of 3, then minus 12. Of course, this whole thing has to be a 12, I mean a negative. So this is negative 30, which is less than 0. Hence what? Maximum. Okay, so the stationary point with x is equal to 2 is therefore a maximum point. So that is that. Then what else? We do the same for x, which is equal to 6. The second derivative here is going to be 144. we divide by 3 times 6 minus 8 cubed minus, this is 12 out of 6 minus 1, then cubed. What does it give us? 144 divide by 3 times 6, that is 18, minus 8, that will be a 10. Then we power it with a 3, and then minus the 12, then out of 5, then cubed, which is 125. What have I written here? 5, then cubed. So we have 6 out of 1 to 5, and this one is a positive value greater than 0. That means the stationary point whose x coordinate is a 6 is minimum. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.